When we're looking at the vertex form of a quadratic function, we have the function over here. The number out in front would either be a reflection across the x and or a vertical stretch or compression. The only way it would be a reflection is if that's a negative number out in front. It would be a vertical stretch if it's a number bigger than 1, and it would be a vertical compression if it's a number less than 1. Over here indicates a horizontal translation. So any number that's in here would be a horizontal translation. If it's minus, it goes to the right. If it's plus, it goes to the left. The K shows us a vertical translation. If it's plus, it moves up. If it's minus, it moves down. Here's the description to write the quadratic function in vertex form. The parent function, f of x equals x squared, is vertically stretched by a factor of 4/3. So before I do anything here, I'm going to do f of x. Oh, I'm going to do g of x because that's going to be our new function. And then it's going to be 4/3. And I'll have whatever's in my x. Then you see it's, and then translated 2 units left. So that's going to be x plus 2, because I'm going left. X plus 2 squared. 5 units down, since it's going down, it's minus 5. And that's it. Nothing else to do. If we're going through steps, we can say step 1 is identify how each transformation affects the constant in vertex form. Then we just write the transform function. So I originally said vertically stretched, that becomes a 4/3, translated 2 units left, and then down 5. Let's try this one. Parent function x squared is vertically compressed by a factor of 1/3, translated 2 units right and 4 units down to create g. So g of x equals vertical compression, means it's 1/3 on the outside, x minus 2, because I'm going to the right, squared, and 4 units down. That's it. The thing with vertex form is that it tells me exactly what my vertex is. My vertex of this function is going to be this and this. Opposite h means that that's going to be a positive 2, and negative 4 is my y. That's the vertex of a function. If I go to Desmos now and put this function in, g of x equals 1/3, parentheses x minus 2 squared, minus 4. If I look at my bottom point of the function, it is going to be at 2, negative 4. That's my vertex. You'll notice it's the opposite of this sign and the same as this one. So my vertex is always going to be given in this form. Okay, let's look at some more examples. I have the quadratic parent function. It's f of x equals x squared. Its graph is a parabola with vertex at the point 0, 0. Describe each transformation from the parent function. So if I look at this first one, I can see that I have a negative here So this is going to reflect over the x-axis. So reflect over the x. What's the difference between reflecting over the x and reflecting over the y? If that negative had been in parentheses, that would reflect over the y. Number 3, here I have x minus 1 squared. Because it's minus 1, it means that I move to the right. So I'm shifting this to the right by 1 unit. Number 4, plus 7 is at the end. So it's up 7 units. Number 5, we have 1/3 x squared. It's inside the parentheses, so that tells me it's horizontal. And it's 1/3, which is less than 1, so that tells me it's a horizontal stretch. Okay, I'm going to leave you to the rest of them. If you have any questions, come on the Google Meet.